In this video, we'll be talking about source transformation. Basically, what it means is that I can transform or replace the circuit at the top here with the circuit here at the bottom, or vice versa. So anywhere in my largest circuit, I have these two sub-circuits. I can replace one by the other. And if I look a little bit more closely, I can see the top one is what we've called a non-ideal voltage source. It's also the same as the Thevenin equivalent model. And the bottom one is a non-ideal current source, which is basically also the same as the Norton equivalent model. So I can transform basically one into the other. It means that they behave identically, or basically they are equivalent. And I can follow the same methodology I used when I was talking about Thevenin and Norton models. So basically, I could calculate the Norton model for the circuit at the top to get the bottom circuit, or I could calculate the Thevenin model of the circuit at the bottom to find the top circuit. So the first thing I could do is I could say, well, I'm going to leave the two terminals open, calculate my open circuit voltage, and for these circuits to be equivalent, this test has to yield the same result, meaning that these open circuit voltages have to be the same. For the top one, open circuit voltage is just Vs, and for the bottom one, it is Is times Rp, and so I get one equation. Another test I can do is where I short circuit these two terminals, and the short circuit currents have to be the same for these circuits to behave equivalently. So for the top one, that current is Vs divided by Rs, and for the bottom one, because there is 0 volts over this resistor, there is 0 current through this resistor, and therefore Isc is equal to Is. And I can find a second equation. And then the third thing I can do is basically leave it open, set the sources equal to 0, so the voltage source becomes a short, the current source becomes an open, and then calculate Rin. And that's also very simple. That's just Rs and Rp, and they need to be the same if these circuits are equivalent. Basically, I have now three equations that will help me to transform one circuit into the other. So I can use this to basically calculate the top circuit if I'm given the bottom one, or vice versa. Now, there's one thing I need to mention, is that it's important that these circuits have to look exactly like this. There cannot be a resistor here, for example, or this is also not the case for a current source in series with the resistor. It has to be a current source in parallel with the resistor and a voltage source in series with the resistor. And this is a mistake that students sometimes make when they do this analysis. So make sure that it's indeed these exact circuits. And why do you ever want to do this replacement is that sometimes it actually makes your analysis, the rest of your analysis, a little bit easier.